relays. They were the precursor to vacuum tubes, and vacuum tubes were the precursor to transistors, and you may be wondering why I'm saying all of this. But basically, they allowed for logic, and, you know, people built computers with relays at one point in time. A relay has an electromagnet on one side, and on the other side it has an armature. And when you power the electromagnet, the armature moves in a position to where it can conduct power between two pins. Similarly, we have photocouplers, or, you know, basically a relay that is silicon. To explain it better, one side of the optocoupler or photocoupler is it's a piece of silicon which reacts to light, and then the other side is a light, like an LED. So when you power the LED, that means that energy can go from one side of the photocoupler to the other, which allows us to basically do the same thing as a relay. Relays are really useful when you have too much current, and you want two separate circuits to control it. You want to control a large amount of current, like 200 volts with 9 volts, then that's what relays are for. Of course, you can also use them for logic, and that's what we're going to be doing. So by default, a relay is an AND gate. And what I mean is that both sides have to be powered at the same time in order for something to happen on the other side of the circuit. So if one side is not powered and the other side is, nothing will happen. But if both sides are powered, then something will happen. As I have learned from Minecraft, the first step of building a computer is the ALU. Or, well, that's the simplest way to do it, is to start with the ALU, because then you know what you're building from there, and how everything's going to work. Well, you can figure it out. Usually you don't know how everything's going to work until you've finished it, but hey. I mean, it's just start with the ALU, okay? That's the basic first step. And the first step to the ALU is actually making the adder. And I always use this simple design. The design I use is a carry adder. It's very simple. Ripple carry. Okay, it's ripple carry. It carries from from a bunch of AND and XOR gates to another set of AND and XOR gates, and it allows us to basically add a certain number of bits, as many adders as we make. So we could make like 8 adders or 7 adders. I'm going to use 7, I think. That's my idea, because then we will have like an extra carry out bit, and it just makes things simple. Okay. Now to get started, I'm gonna go ahead and show you all what this would look like on paper. So here we have 2 XOR gates, here and here. I don't know if you can see my mouse. Hold on a second. Let me check. Oh no. Okay, well, this guy, the one I just selected, is an XOR gate. And the other one, who he's attached to, is also an XOR gate. Now these blue lines represent our inputs. For example, this very first blue line, I wonder if I could put like letters here so you can all see. This very first line is A. The second line is B. And the third line is carry in. So basically, from the previous adder, we take a logic from this OR gate. That's not how you spell OR, but we take a output from this OR gate, and that's our carry out, which goes into the next carry in. So that's the carry in, and then. But we don't need this gate here. We don't need extra, so basically what you'd do instead of using an OR gate is you'd hook 2 wires, just a wire there, and that would mean that whenever one of these guys is powered, the power will automatically go out. So this gate doesn't need to be here. This is an AND gate. Okay, this is also an AND gate. and then these are both XOR gates. So that's the basics of what we're dealing with here. And then I ran into a slight issue with the whole project. I don't know how to make an inverter.